I'm actually here 3 days this week.
And I wonder why. It would be a very boring lecture if you weren't here.
But next week I will be away 2 days, so don't worry. I don't going to pest you. It was kind of a challenge. Do you have sound in this? Okay. It was kind of a challenge to find out how to position myself, because between my colleagues, and kind of showing you a little about what have I been doing over the years. And still not going too deep into science. I left that to Monica because that was really in depth. But I thought I should rather give an overview of where have we been, where are we, and perhaps a little end what can we do in the future, because I don't believe in staying in the same place all the time. I've been staying here for 32 years, yes, but that's perhaps why I can move around as I feel like. So I gave this name, and it's actually the storyline. This presentation will, if my voice lasts, will be where I started, clones to improve plant performance. There's many years of work on that, actually. Then we moved from the clones, moved to the photosynthesis. We moved into dynamic climate control, so moving into understanding how plants reacted to climate conditions rather than technology. We've been playing recently more and more with LEDs in different directions. And Kai, you should be happy that's one for your greenhouse. Then we've been talking about phenotyping, and the future is. And actually, Michelle, you are not the only pickup I had from the US. Kai, I picked up as a postdoc in Pennsylvania.
But after me.
After you, yes. So it can be beneficial to go to the US and pick up people. But actually, I started all my work in the forest. One of the wettest summers ever in Denmark, we floated away working on pollination ecology of honeysuckle, Caprifolia, where I looked into bumblebees, how they pollinated it. Spent 2 summers or more out there. That would not be possible these days because of the new reforms of the progress of the students, so you can't do real good research projects. But okay, this one resulted in 2 papers. So I started quite good in the beginning. That was before I was hired here. But then I was hired here for work on clonal selection of plant material. We didn't really have a tradition for publishing so much, but my boss at that time, Ole Fogh Christensen, was really encouraging me to try to get some of the knowledge out, and we managed to get some papers. But I think the advantage of the clonal selection work that we could actually improve the quality, uniformity of the plants from the growers. So we more or less collected plant materials from different growers from the same variety, picked the best one, and suddenly you could improve your uniformity, so you could sell all the plants, or not all the plants, but more of the plants at the same time at a better quality or generally higher quality, perhaps also better pulp. So that saves money for the growers. And that was a time where you really had, sorry to say, a lot of money. You had a lot of things you could put in between, play around, and we started working on photosynthesis that time also. But it was actually what you could call phenotyping, because we were using species, we selected them on different conditions, we found the best ones, and we continued that. So when I'm looking when I wrote this, I realized this actually, I started phenotyping in horticulture in '84. But then we had to do something. Then I went into some research in relation to my PhD, where we tried to look into physiology of the clones. We saw some varieties were really strange, behaved differently. So we tried to connect growth and clonal reactions, photosynthesis. The correlation was absent. There's no correlation between photosynthesis and growth as such. But it showed up that a lot of the varieties actually had a lot of plasticity, so they were able to adapt to different conditions. So they were better at using the dynamic conditions we have in greenhouse. Even though we tried to keep a constant condition in greenhouse, we still have some dynamics, and some of them were really performing much better in that case. And you could see that that's why they had higher photosynthesis. So suddenly we had fluctuation conditions, it was working better. So it was quite natural. So when we started talking about dynamic climate, and that where we started actually in a collaboration with Copenhagen University, or Landbrug Højskolen as we called last time, and we applied for a research project, they applied for a research project, and the research council said, why don't you sit down and talk and do a new research together? So that was actually not the first time I met Jesper, but almost. And after some discussion, we ended up with the dynamic climate control, and all the growers here have seen this 1,000 times because we spent hours and hours of talking about how do plant reacts to CO2, to light, to temperature, and what happens if we combine them. So this was kind of shaping the background for IntelliGrow, which has been pretty well used by the growers. I still have a feeling we need to brush this off and talk about it one more time because some growers have forgotten about the advantages. So perhaps we should spend a little more time of doing Bruno's way of promoting the things. You have a very good brochure about light and measuring light you should actually take a look at. So I need to translate that into Danish. But IntelliGrow, well, you've heard about it. When we normally control the climate in the greenhouse, we have some set points, which might be good or might be wrong, but they're based on years of tradition. Same procedure as every year, as you have just before New Year's Eve. But what we then try to move all these processes into some kind of intelligent aspects, in our case using our own sensors, because we realize we need much more sensors, but creating a model system which were quite good, working perfectly in our greenhouses, and we could actually stuff it down the throat, to the growers by explaining. I think we spent many hours also with the young growers talking about why you do that, talking about physiology, because the alternative will be some kind of black box and nobody will be using it. So IntelliGrow was working, and well, the classic picture we are always using, that the standard climate looks like this. If you want us grower to pick it, they can't agree. They will usually take this one, but they should actually take that one over here, because then you save 30.1% of energy. So that's pretty simple, and we introduced it by people telling the growers, just do one step at a time. You don't have to invent the wheel. You don't have to create a lot of chaos. But of course, we had long discussions about the issues of predatory mites, insect. We had a PhD project running in Copenhagen looking into it, but we had it closed. But there was one major advantage, which was kind of simple. We had much less trips in the energy-saving climates, and obviously we closed the vents much more, so the poor guys can't fly in or move in. So the stuff and dynamic climate control was pretty simple in a way. We just allowed the fluctuations to run more natural. Put some limit in if you need it, but the important part, the CO2. So more CO2, much more CO2, and even much more CO2 would be used. So we result in higher photosynthesis and in many cases more compact plants. So there was really there's no good reason for a grower not to introduce it. And I need to spend some time. No, in most cases people don't have to spend time using it. But I realized when we are talking about now again, we need to come up with a story for the younger growers and the new growers coming into the business. So all over, it was kind of a more dynamic system we developed based on solar energy. And after a few beers, some nights, I think Jesper and I agreed that we have spent a lot of time developing this, but actually just measure the light and control based on the light level. So we had spent a lot of modeling work, model understanding, to reach that point. But the point, and that was still in the applied research period, save energy without costs. And our colleagues in Germany has been copying our Dutch colleague, call it something else. I'm going to Norway in 2 weeks and talk about dynamic climate control because they have a dynamic climate project. I think that they could have just asked, but that's not the point. And it works. Energy saving is, of course, never-ending story. And here's some of the energy consumption from nurseries, the public data, and you see a very strong drop in the energy use on heating, artificial lighting. And the growers themselves say that IntelliGrow and new investments in insulation has been the case of this. So Danes are, in that case, way in front of the Dutch. But, they always come with a but. The problem is that the energy for heating is going down, the energy for electricity has been increasing. So when you make a new installation, you just add, when you build a new electricity installation, which are more efficient, you add more lamps. And from a political point of view, it's not so sexy because they want to have the CO2 emission to go down. Perhaps not in the current government, but at least so there's still some challenges. There was some challenges. And we also see that we have a lot of changes in the ability of the plants to acclimatize. So this is an example of chrysanthemum grown at high light. I stole the data from Eva. Chrysanthemum hibiscus, and then they were grown under low light conditions, and the chrysanthemum really drops when the light level goes down, while the hibiscus drops less. So the hibiscus has really good use of the high light conditions all the time. You have to have that in mind also when you think about how you make installations. But normally, anyway, we don't put more light than 200 micromole artificial light on. So it's really, the different species react differently, and that has been the core of a lot of my work, that we need to understand different species. Perhaps it's based on their natural origin. So like hibiscus coming from a tropical forest, chrysanthemum from a Chinese field, originally at least, when it was bred 200 years back, or 2,000 years. So the work, we quite naturally, when you saw, well, we have solved the problems in IntelliGro. The software is a bit slow. It's being implemented in the climate computers. Agrotech is developing a kind of plug-in for the system so they can actually show to growers simply what's going on. And I think that's one of the important issues for us. We can't do that kind of a development. But if we have companies who can take some of the ideas and plug it into systems which can be commercial, that's the kind of success rate for us. Light. Well, we know that higher daily light integral, so higher light level per day, increase the carbon gate, and we can just pour on more light and pay the bill. That's not realistic, but we also know that we have some differences in the responses. This is a hibiscus where we just turn on the light, or a rose where we turn on the light. And it shows very clear that hibiscus is a slow starter. In Danish it's called a bee person. Will wake up late and be slow in reaction. While the rose is quite a fast starter, and it's actually up to very high light level, or adapted very quickly after 10, 12, 15 minutes, which happens to be the time where the sodium high pressure lamps will turn on fully. So that's pretty good. While the rose, the hibiscus, well, one of the hibiscus growers commented, well, he shouldn't switch off the light too much because then it would kind of lose production. So that was the idea of that we could continue in some ways. So we started some kind of studies of dynamic reactions also. And Helle has been working quite a lot on the gas exchange. Actually, one of the old gas exchange equipments. And so we tried together with Bo from STU to develop a sequel where we had more dynamic lights. Bo I actually met. We talked about pervasive computing, distributed ways of running computers in greenhouses, and he came up with the idea, couldn't we do something about that? And it's kind of, he's a good example of, it's fun to work with people from different fields. My problem is I don't understand his computing, but he tends to understand at least some of what things I'm doing. Says more about me perhaps. But the basic Dynalight was still have the core of IntelliGro running the photosynthesis and models, so we can do the control dynamic. But in Denmark, on Scandinavia, we have these horrible fluctuating energy prices. The fluctuation has declined a little because we put a power line to Copenhagen and they suck up all the energy and equals the prices. But the weather forecast was actually a forecast of how much light, not overcast, but amount of sunlight we're going to have could be used to reduce the amount of light or supplemental light in the greenhouse, and thereby the energy. Our big scare, this is one of Katrine's figures, was what happens if we have this condition. So a sunny day, we have little light. On a bad and boring day, we have a lot of artificial light. But we get because of the price structure, we want to save as much energy as possible. We get a very fluctuating light. So the first question we had, of course, is this possible? How do the plant react? And if we look at, this is probably your data from Jülich, Katrines, yes, I think, once upon a time. From Denmark, okay. We also played. Well, the plants really don't, if they have a fluctuation day, long days, short days, they don't care much because they open the stomates and as soon as there's light, their photosynthesis. So a chrysanthemum in this case couldn't care less. The more light, the more growth. So the first check mark, running this dynamic light didn't damage the plant. Because that would be the biggest scare, of course, if we invented something which was not working. We could see it in Telegrow that if we pushed the temperature too low during the night for some species from tropical origin, then they wouldn't cope with it. It took some time sometimes to find out what was wrong. But the first generation experiment showed, well, pick a plant, no problems. Knud Jebsen took the software and tried to run the greenhouses, and Kai said that he saved 16% of the energy. And that's a good example that we have run projects where we have a close involvement of growers and have a lot of discussions. When we have steering group meetings, they are not quiet. There's some shouting and discussion and planning going on. And actually we've experienced from GeoDP, the funding body, that some of their reps like to be there because there's some discussion going on all the time. It's not just presenting data. But there was a challenge, like in Kalanko, Campera, sorry. One of the varieties really dropped the number of flowers a bit. But still, it was a pest for Helle because she was counting 300 flowers or she was counting 175 flowers. For a consumer, it might not matter so much. But this means that it was two different species with really different requirements. It was applicable. And in Kalanko, we tried to develop the system further on, so having LEDs and running both the standard conditions, the dynamic conditions, so all kind of different variations. And if I remember right, Kai liked this one best, but I'm not sure. But they look for an untrained eye, well, this one is a bit smaller, the other ones are quite uniformly developed. But it's not without challenges because when we move to LEDs, we have a lower leaf temperature, and so we have to play with the compensation. And that is not so easy in control systems. So when we started LEDs, we actually moved a little more playing around working with SDU. And if you see a little face hiding behind here, there's Terry Harris, who did most of the work. He was actually employed in SDU, but I think he spent most of his time either here or in the labs in there. He didn't use the office in there. So when we looked into that, we found out that it's really complicated to compare. Most labs buy a cheap Chinese LED and test. And my colleague in Norway say they buy normally 20, and then after 1 year they have to throw out 10 of them because they break down. And they are not usually the same. If you measure the spectral distribution, it might vary a little because it's cheaper. And one of the things that's been done a lot in closed environments, you can't transfer it to a greenhouse because the greenhouse have, even today, a lot of light, natural light. And that kind of removes or smoothens the effect of the treatment we want to have. So it's not so easy. So if we really want to have these effects that Monica has been talking about, kicking the plants on a sensible place to promote specific compounds, we have to do it in the closed environments. There's no discussion about that. But of course, since most of the plants that you have been talking about are smallish mice, it's actually not a problem. So you can really, in a closed room, you might be able to control the way that plants are growing. And I see a lot of overlap or synergy here because we can play with how to grow the plants and perhaps trigger the compounds, find ways of developing the compounds, and you can work more on the mechanisms behind. We have a white tish, which is blue actually, and red and blue. And I think you can see that this is very dense, nice, compact plants. This is kind of not very dense. The other varieties up here produced at the same time. Well, this is kind of okay, but these has some damages. So you can't just walk off, buy a lamp off the rack and test or believe that it's working. And that's one of the challenges when we talk about these closed environments, multi-layer systems, whatever we want to call them, urban farming. There are really differences between the genotypes. This was a constant light combination. We might have an advantage of having more combinations or changing combinations. And the current city farms, I've seen them for Philips, which are the big guy in this business, love constancy. It's kind of, so it's even worse than before dynamic climate control. And the issue on energy, well, I don't know who is going to pay for these salad lettuce in Denmark for 20 or 25 kroner net price. But there's a really market. Cannabis is really big in the US and Canada. So I've just been talking to a Norwegian guy. He's installing 400 up to 1,000 micromoles of lice for cannabis production. Because with cannabis, the content of secondary metabolites increase with the higher light level. And it probably increases also with more UV. Unfortunately, we're not allowed to test that, but it could be fun. Could sell it after, no, sorry.
California.
So the next challenge we had was one we are talking about all these components of energy. We solved the Dynalite, we solved the Intelligro, and we just saw that we have huge differences between different varieties and species in stomach conductance when we had different humidities. So that was part of the work from Haptemo, who is also gone to Wageningen, and really going in depth, but still working with the growers. So he nicked some plants from Geert, and I remember one comment from Geert was, I can't use 90% of this, but the 10% is interesting. And that's in a way for us a pretty good, to me it's a good story that, even a PhD student who doesn't know anything about horticulture, agriculture as such, or not working with farmers, can actually work with a farmer and get some kind of mutual benefit. Because what we saw in that case, that if we grow some of the varieties at high humidity, they didn't care less. Others were having permanent open stomates, so they were transpiring a lot all the time. And that means post-harvest, forget it. They would have really poor quality. And he also happened to find out it's linked to the amount of foliar ABA, not the ABA as such, because if we drought stress them, they would react. But since the plants are really well watered, growing in high humidity conditions, it was pretty critical to select varieties which are suitable for that. That gives a challenge now, because when I want some new varieties of Geert, I can't get some of these old varieties anymore. But we're continuing that work, and we have kind of upgraded our toys. We have a good collection of toys, I would say, where we can actually measure individual plants and follow up. And again, but that needs to be moved into some kind of modeling concept. So we both understand the mechanism, but also the models. And I think we have an advantage. We have good collaboration with Agrotech in that case, and with the growers. So we actually, I'm just trying to be the spider in the net, getting these people together. And that's the fun part, even though it requires showering a little. The challenge is, I don't like Philips' concept for very stable conditions in these city farms. So we need to find, I think we could be one of the guys starting working and developing dynamic closed environment systems. Our own climate chambers can run completely dynamic. So that's the first step. We have the toys, the tools in-house to test different ideas. Humidity will be a challenge. Not only the insects are being affected by the lower night temperature, but the humidity really can be a real challenge. So we also work with technical companies trying to find solutions for solving the dehumidifications, but delaying the technical solution as much as possible. So reducing investments, using our knowledge about plants to develop the ideas. So in a way, what we want to do is make management of stomates. The hardware that You showed a picture of, oh, not that one, but they can actually be used to measure more or less water loss from plants or the movement, especially if you have thick stems. So I think we can develop more based on our knowledge, stress management. And one of the new toys in town is the big data. You've heard about that. Everybody is being pulled into big data. But again, together with SDU, I think we could have a new way of crunching all the climate data or production data from the greenhouse and see where could we do something without damaging anything. So now we moved from the huge leaps to small steps at a time. But I think back to the clones, it comes back to we have to improve the genetic material. We have to find plants or genes which are better in using the light. Perhaps someone with higher humidity tolerance, which we have seen already. Post-harvest is equally important because you can try to produce very good plants, but they need to be able to tolerate the horrible conditions they are being subjected to when they're being shipped and standing in the supermarket. So I'm always sad when I see good plants being killed in the supermarkets. I don't know whether you can do anything, but the better genetics they have, the better chance they have for surviving. So our next foot here has been more or less to look into breeding material, screening for different characters. And that was the aim of the phenotyping work we've been involved in, trying to look into genetics, climate and management. So how can we develop methods which are good at characterizing the physiology? I'm not able to do the molecular biology behind it, but fortunately we have found collaborators who can work on that. So we can both do what we are good at on the whole plant level, but work with people who are good on the molecular level. So generally we have been from the heat weed project, again together with Copenhagen University, we developed some kind of simple screening techniques where we use chlorophyll fluorescence for screening heat, temperature, water stress, whatever. Water stress doesn't work. We tried that one more time and it still doesn't work. So still understanding why do the plants react like that, and then apply crossing if possible, or QTLs. QTLs are easier than crossing because it takes, depending on the species, might take some long time. But this shows very nice. It was one of our master students' work here on one of the wheat cultivars, that it actually matters when the plant is being stressed. If it's in the flowering phase, you can more or less kill it after 40 degrees in 3 days, while the younger plants were not really stressed at all. So the later we gave them stress, the more sensitive, which might have an implication for using UV or blue light later in the phase of the plant, in the flowering stage. I'm not sure, it could be an idea. And this one I shouldn't have brought because it's too complex, but again, if we grow the plants in a slightly less higher temperature before we stress them, you can see the FVM in this case is really dropping. The plant is very stressed, while in this cultivar down here, it's hardly stressed by the treatment. So we can alleviate some of the stress effects simply by lifting the temperature a little or adding CO2, which the previous also showed. So if we can prime the plants with high temperatures, it can actually reduce the stress. So you could say during the summer, if we have a small heat wave and a strong heat wave, it will be less stressful for the plants if we just had a strong heat wave. And there are huge differences in varieties here, but there are also huge differences in the origin of plants, because we have collected faba beans from different locations, from Afghanistan. Well, I didn't go to Afghanistan, don't worry. The seed bank made that work. But we have some differences, and it's not really linked to the geographical origin. So Afghanistan is least stressed, but then you have Germany, Sweden, Russia, and Sweden. So we can't really alone see on the reactions where they come from, but it's still a very nice tool to think about developing. The idea of this faba bean was to try to find some of the varieties which cope better with a lower temperature, so we could start growing them more in Denmark, like as an autumn crop rather than a spring crop. We need proteins. But one of the side effects, we also made them heat stress. And coming back to my pollination story, well, we saw that if we had the greenhouse 25 degrees and or 30 degrees, we had huge differences. And this black marker, or bluish black marker, is actually a hint for the pollinator that flowers here, this one is losing it. So that's simply negative, could be a negative effect. That means it wouldn't be pollinated, and which mean you had no faba beans harvest at all. So there's some fun things. Phenotyping horticulture, I think we can do, as I mentioned, started in the clone, which I regard as phenotyping. It could actually be pretty important to screen more plant material from the nurseries, like for more energy friendly plants, plant that can tolerate lower temperature, slightly lower temperature. We can have a very fast screen for literally anything that we can measure. We can mix different combinations. So if we have high CO2, will that we have more stress or we have less stress? We can screen for higher productivity. So altogether, I think the tool is pretty efficient. And we might not have the used toys in town for all of this stuff. This was one of the toys, I think. Don't know whether it's working. It's working. Might be working. It's a Windows. Sorry. It should be running. But on the other hand, we have a collaborator, we have a network in Europe on phenotyping where we can actually access their facilities more or less for free and test our ideas if they are good enough. While we will focus in our phenotyping work on the knowledge about physiology and some of the tools like the drought spotter, the equipment in the lab, or the 3D scanner we have in the greenhouse. So altogether this can result in more sustainable production. And where do we go from here before lunch? I put up kind of 4 pillars, chairs, for kind of creating a chair for where do I think I'm working. The blue ones are perhaps more new ideas how to come on. These are continuing our work with the growers. The plant developing and development is more kind of, there's a discussion in the agricultural industry now that we need to have a more increased production in the fields. But how can we do that by understanding the design of the plant, the photosynthesis of the plant, light capture of the plant. It's also in some cases called ecosystem services, which is a horrible work, but it includes both understanding of nutrients, plant reactions, but also insects and biodiversity. And there could be a lot of combinations working with our people in horticulture, in vegetables in this case. But phenotyping, we clearly want to work more on these dynamic effect of repeated stresses or multiple stresses because nobody else is doing it. And our colleagues are kind of can't do it because the big facilities doesn't allow you to run so frequent measurements as we can with the 3D scanner. So we can actually follow them continuously. But here I think what we could do, as just one of the wild ideas, we could perhaps participate in making intercropping systems which are better for capturing the low light conditions. In terms of the applied science, well, energy saving new production systems, creating plants with specific characters, and that turned blue because I think it might be more basic work anyway, because you need to understand why. The climate energy management, big data analysis, working with other people again, humidity stomal conditions. So I think that's a kind of a 4-legged chair, which at least you can sit on. You shouldn't have a 3-legged, and you don't have to stay on 2 because it's perhaps a safer way of developing the work that you have more things. And in a way, it links to Michelle's comment about my jigsaw puzzle design ability. Because you need to pick people from different environments and get them to talk, trying to understand what they are talking about, which can be a challenge sometimes. But we knew already when we developed the Dynalite. I think we invited 10 of your students down here for a lunch and showing around. And most of them turned up to be make master's projects afterwards because they realized, oh, that's fun. They know what they're talking about. The greenhouse is a high technology business and it can be used. So making students that you don't know the field of curious in what you're doing is also one of the big challenges. But that's again back to communication. So most of this work, or all of this work, perhaps besides the first part of clones, has been done a lot of collaborations. So I'm not as responsible for all the kilo of work. A sad story, 1 kilo of work. But actually it came back to Ole Fogh Christensen, who hired me in 83, 4, which was a bit interesting because I was a biologist, but I had publications, but I didn't have a formal horticulture degree. It came later. So he dared to hire me, and he might have been tired sometimes because I had some ideas. Then Jesper and I got together and we formed this team on IntelliGrow collaboration. And well, that has been probably our most successful international activity. And then we teamed up with Bo and trying to rewrite IntelliGrow and finding new ways of handling the climate control, which was a really challenge but fun. And he has some new ideas and I have some new ideas. Sometimes we get together. Katrine, who hopefully soon can become a associate professor and has been really good at working and sharing and joint work for many years. And then the technical staff, which I might be pushing too hard sometimes, but they are really doing their best. And the most recent acquisition, so to say, is Benita, and she's trying to keep me in control. Which, but that's really, since I might not be in my office all the time, as Michelle hinted, it's quite good to have a base camp who's really willing to do the work all the time. They can try to call me. I've only been off the grid for 2 weeks last year. And then we have all these students from all corners of the world which have different times of enthusiasm, but they're really very nice to work with. It gives them some kind of social challenges sometimes when you have different people having different ideas. But we try to solve it in a team all the time. And then of course, Eva, which I've been working with married for many years. And then collaborating since the 90s, she came to Denmark. And I didn't add the funding bodies. There's not enough space for that. But shouldn't have been, okay. That was your attention, that was the thanks for your attention, but this is a workshop. And you won't get any food before you have some questions or challenges to this. But I think the important issue, that's my challenge when I'm working it, how do we get our innovative ideas, good right ideas of course, to be used. Bruno has shown some very nice examples of really trying to demonstrate, showing, talking, which is very impressive in Belgium. But I would just as much see how can we use more our results from our plant production, how to know to grow the plants, design the plants, can be used in food and health. And, Monica has shown some very good examples. We just need to upscale it, get it working. But that's the discussion. And how on earth do we find this balance between the science and publications and the industrial interaction? Because I'm being measured on impact factors. We have some KPIs for impact, but the scientific papers, students, patents are actually the ones counting most. We have Michelle has managed to get impact factors in terms of publication interaction with industry pushed higher up. But our colleagues at 8000C, or Aarhus Classic if you want, do not really appreciate it. So that there's some kind of, they come from down there, you do so much applied research. So it has been a challenge to push our research into higher level papers, and I think we have been recently we have been pretty successful in doing that. So suddenly they open their eyes and say, well, might be worthwhile working with you. That was my words, and now I'm going to cough. But any comments or questions, or you're just completely fed up and hungry? Benita says yes, so I better continue.